Welcome to the DUCO Collaborative Robot Training course. Multi-collaborative robot supports Modbus industrial bus communication. When the PLC or PC communicates with the robot Modbus, the robot can be both the server and the client side. The communication interface of the robot control cabinet is a LAN interface. 1D robot as Modbus server, PLC as Modbus client side. The first step is hardware wiring. Connect the PLC communication network port with the LAN1 interface of the robot control cabinet with a network cable. After the robot is powered on, it can be used as a Modbus server to monitor the connection status of external Modbus clients. The second step is to set the Internet Protocol address. Click on the username, System Settings, and Network Settings, and the interface will jump to the Management Center. Click on the Wired Network Interface Card LAN Interface Settings. Enter the Internet Protocol address assigned to the robot. Save the project after returning to the robot interface. The third step is PLC programming. Cymatic S71200. 1. PLC writing Modbus client-side program. PLC add the required CPU. Modify the IP address in the CPU. Add FB function block. Add the required variables. Set up multi-communicable IP and port numbers. Start writing a Modbus TCP puller. Write the corresponding variable according to the instruction. The fourth step of communication testing. Manual communication test. View I/O function output signals in PLC software. Write value to robot I/O ordinary output signal in PLC software. Write a value to the I/O output signal of the robot end tool in the PLC software. Write value to robot register word input signal in PLC software. View the corresponding register input value in the robot interface register page. Word output write value on the robot register page. Check the corresponding address signal status in the PLC software. Programming communication test. Write the program on the PLC side to realize the start of the main program of the PLC control robot. Stop and dial robot subroutine and subroutine B in turn. The robot side is first in the interface register function input page. Configure function input 1 to run main program respectively. Function input 2 is configured to stop program. Then configure function output 1 as program running status on the function output page. In the program page, create a new main program, subprogram as SUBA, subprogram B SUBB. Then drag a script function block into the main tree. Use write_reg command to reset registers bool output 1 and bool output to 2 false. Realize the function of initializing output register after program startup. Continue to drag in the while function block to configure its parameter to loop all the time. Realize loop execution of main program. Drag in the script function block to reset registers bool output 1 and bool output to 2 false again. The purpose of this operation is to reset the output register before each loop execution. Drag in the wait function block and configure the parameter as conditional expression. Add a conditional expression to bool_reg_ in 1 == true or bool_reg_ into == true. Realize the waiting of PLC input signal. Drag in the if function block and configure the parameter as conditional expression. Add else if function block. If edit conditional expression to bool_reg_ in 1 == true. Else I've added conditional expression to bool underscore reg underscore into equals true. Then, in the if function block undefined, drag the wait function block to set the delay of 3000 milliseconds. Drag in the script function block and edit the conditional expression to bool underscore reg underscore out 1 equals true. Drag in the subprogram function block and select the subprogram suba. Drag the wait function block into the undefined section of the else function block to set the delay by 3000 milliseconds. Drag in the script function block and edit the conditional expression to bool underscore reg underscore out 1 equals true. Drag in the subprogram function block and select the subprogram sub. Save the program when complete. The above operation realizes the main program according to the bool input 1 and bool input to signal to the subroutine, btransfer. Finally, in order to facilitate the observation of the subroutine's allocation, add message function blocks to subroutine as suba respectively. Enter the message successfully called subroutine. Add message function block in subroutine B subb. Enter the message successfully called subroutine B. Finally, enter the function into the running program in the register and select main program. Write PLC program. The program is written and the test is run. If you use scripting to rewrite the above program, the instructions for reading and writing registers should be replaced by write_reg and read_reg. Read_regnum type in _out function first argument is the internal register number. The second argument is the register type. 1 is the bool register, 2 is the word register, and 3 is the float register. The third parameter is input. Output 0 for input, 1 for output. Returns true or false when the read register is of type bool. The return value is number when reading registers of type word and float. Write_regnum type val function first argument is the internal register number. The second argument is the register type. 1 is the bool register, 2 is the word register, and 3 is the float register. The third bit parameter writes different values depending on the register type. Script programming implementation. The program is written and the test is run.